Erica Johnson here at Solar Power International 2019, Salt Lake City, Utah. We're here at the Future PV Roundtable.
What does it mean to have a stable grid? Basically, it's a very simple way of thinking about it. When you plug it in, you want to make sure that the voltage on that line is the right range, that when you plug it in, that your light comes on, right? I mean, those are the two things.
The first panel focused on how solar and batteries can provide the essential services needed to keep the grid stable, including regulating voltage and frequency.
Usually at the local level, you're trying to control voltage, and at the transmission level, you're more watching frequency and controlling frequency. That's an exaggeration. You have to kind of do everything here. But inverters, of course, are computer-controlled electronics. You can emulate pretty much whatever you want it to look like with inverters. And we're getting, I think, smarter and smarter about how we move toward more advanced grid uses.
But this is not happening in a static grid. One of the big questions that was addressed at the roundtable was the role that electric vehicles, or EVs, will play.
EV is the next disruption that is coming to our grid, right? We are shifting from consuming fossil fuels to power our cars to consuming electricity, which means that in the future EVs will be one of the largest power loads that we have on the grid, because most people drive to work and drive back to home and use commercial vehicles at the same time. This also means that these loads will become peak loads. The best way to handle peak loads is solar and storage to offset these loads. That's one thing. Also, EVs are basically a big battery on wheels. So you can actually leverage this battery as a storage infrastructure. Basically, EVs, in my view, will become one with the grid.
Another big issue is scale and the different role that distributed resources can play versus large-scale solar and batteries.
But I like that story about we can't produce everything we need locally. So let's talk a little bit about distributed generation and what that mix might look like.
I would frame it a little differently, that diversity is very beneficial if you want a reliable and economic system. I think we need it all. You could do it all locally, but it would probably be more expensive and less reliable. The more economic way, I think, is to take advantage of the diversity and use the best features of all of these different capabilities in a large system in a coordinated way, and that ends up being more economic, more reliable, and I think overall more sustainable in terms of quickly getting you to sustainability goals.
Second part of the Future PV Roundtable delved into the wealth of new cell and module technologies that have become available, all of which promise higher efficiencies.
The question becomes, higher efficiency at what cost? And can these new designs really scale to mass production in a cost-effective manner?
The highest efficiency for the lowest or most appropriate cost is different on the rooftop than it is in a large utility scale plant. In the rooftop, value of the real estate where you're putting the modules is very high, and so there are certain additional cell technologies that are being introduced that are very high efficiency that will initially be adopted in the rooftop space. Mono-PERC is today's leading high efficiency solar technology that probably has an additional 1 or 1.5% of efficiency at the cell level that can be squeezed out until it gets to probably 23.5% conversion efficiency. Then the next technology needs to be introduced. Probably that will happen within the next 3 years. Heterojunction is a different cell technology that looks very compelling right now. It is high cost.
I think that evolution of PERC, we're going to continue to see up to potentially 24% is possible with improved wafer metallization and cell line control.
A lesser-known high-efficiency technology which was introduced at the roundtable was TOPCon.
I can simplify just one sentence to TOPCon. It's like a thin oxide layer has been introduced to the silicon cells, which can reduce the recombination losses for the cells. So it can increase the cells efficiencies compared with the other technology.
But with new technologies, there are always new risks.
So you mentioned LETID. Are there any other degradation routes with PERC that were unforeseen that you're finding?
I think one interesting thing is LETID for bifacial can be different on the front and the back. So even though it's still same old LETID degradation behavior, that's a new finding for bifacial. Every time we introduce a new technology, there is some kind of new finding of degradation I would say.
Another great Future PV Roundtable here at SPI. Thanks so much to our sponsors and all who have joined us. We look forward to seeing you next year.